Hi, good day, everyone. So today we are going to talk about simple linear regression analysis. And we will start with the fundamental logic. Yeah. So what is regression analysis actually? Linear regression analysis to be precise. Uh, Actually, linear regression explains or predict yeah, a response dependent variable based on a linear relation with its predictor or independent variable. So we try to get an idea on what the dependent variable will be if we have a specific value of independent variable. Yeah, and then how we can do this? Yeah, usually let me draw it here. Usually, people have records of data. Yeah, let's say for a specific company, a shop have recorded their sales performance. Then, sales performance for a specific month, yeah, based on its advertisement budget, yeah, ads budget that he spent during the month, yeah. And then, yeah, for example, for month one, yeah, this is month number one, the ads budget he spent is 2 million rupees, and then the sales turns out to be, let's say, 4 billion rupees, yeah. So, yeah. And then for month two, he spent 3 or 5 million rupees in budget, and then the sales turns out to be, let's see, 6 billion. And then three, for example, he spends about 3 billion rupees, and then the sales turns out to be about let's say 5 billion rupees, and so on. Yeah, let's see, for the fourth one, we have an ads budget of 4 billion. Yeah. And then the sales budget is, as then the sales performance is also 5 billion rupees. Yeah. What people can do, yeah. So we treat the ads budget as independent variable, and then the sales as the response or the dependent variable. Yeah, we can simply plot the data, yeah, in simple Cartesian axis, and then simply make a scatter plot. Yeah, for example, okay, the ads budget is 2 million, 1, 2, and the performance is of 4,000. This is 2, this is 4,000. And then you make a dot, for example. Yeah, and then the second data point, okay, 5 million, 3, 4, 5. Then you see that the performance is 6 billion rupees. So I put it here. Yeah. Okay. And the third data, okay, we have 3 million rupees, and then the sales turns out to be 5 billion. And for 4 million ads, also 5 billion. So by plotting the ads budget, yeah, as the x-axis or the independent variable, and also plotting the data in terms of sales, yeah, the pair between the ads and the sales. By plotting here, we can also already see a pattern, yeah, that, as the ads budget goes higher, the sales performance tends to also increase. Yeah, we can see that there is a trend, upward trend to the right side. Yeah, And what regression analysis tries to do is to find the best fitting straight line or scatter plot between the outcome, or the independent the dependent variable with dependent variable. So the idea is to, let me see, to construct a straight line, be it like this, be it like, for example, like this, be it like this, which which best fit, constructing the best fitting lines which can predict the outcome of the dependent variable, predict the outcome of the independent variable based on the dependent variable more accurately. So for example, if I use the green line here, green line, so I put, it's okay, green line. Let me see, pointer. So if I predict the sales, based on the ads budget, so for example, ads budget 2 million, and then I use the line of the green line here, then using this line, I can project, I can estimate that the sales budget will turns out to be, here is about, let's see, 4.5 million, and then for 5 million, using this, but the budget is, it's accurate, it's actually 6,000 billion, 6,000 million, which is 6 billion, and then for the 3 million ads, we can see that, it is a bit more than 5 million. Then let's see, 5,200 billion, and then so on. And for 4 million, we estimate that, it close to, this is 5, let's see, 5 million, let's see, 5.5. Then, if we can see, if we focus on the green line here, so there is a predicted value, a predicted value is the estimations that come out using the straight line or the regression function, and then there is also an actual value, right? The idea is, how to to find the best line which will lead to the smallest overall error. If you see here, for the green line, actually, the prediction error of, if I put it like this, y dependent, and then y minus y hat, is, then the error is minus 500. Here, 6,000 minus 6,000, the error will be 0. 5,000 minus 5,100 minus 200, then 5,000 minus, this is 0. So so we have, we have an error, 2 errors. And then if we use either light blue, we can also do this comparison with the light blue, with the light blue line or the dark blue line. Dark blue, if for example with the light blue, then if we spend 2 million rupees, then and then we write down what the sales will be, and then we can compare what is and then we can calculate what is the error values. Yeah, and then if we compare these three lines, and then we make the out of these three lines, which lines which lead us to the overall minimum error prediction value. Yeah, and that will be the best fitting line. Yeah, and out of all the alternative. Yeah. So yeah, so that's basically regression analysis. So you have a dependent variable, an independent variable, the x-axis, and then dependent variable, the y-axis, and then you have scatter plot, and then the function. Yeah, there are combinations of straight line that you can build. Yeah, and the idea is to find the best fitting line which leads to minimum prediction error. Yeah, so here, yeah, so regression is essentially finding the best fitting lines, a line that fits the data best, which will be the one for which the unpredicted error. Yeah, so basically the equations of the straight line is, of course, yeah, this is will be y equal a constant plus constant of 1 dot x, yeah, xi, yeah. So it will be fitted because it's straight line, and the functions is also straight line. Then we need, yeah, and then of course in building the straight line, you can build it like here, like this, like this, like this, yeah. And then the idea is, to find a straight line that will lead you to the minimum error. What is prediction error? Yeah, prediction error is the deviation between the actual value of the dependent variable and the predicted value. Yeah? If you make a summation out of it, then you can choose which line is the best one. Which line, whether we have the line number 1, we have line number 2, number 3, number 4, number 5, number 6, and out of these six function, you pick the one which which have the minimum value of prediction error. I think that's the main idea. And the equations, yeah, and then mathematically, yeah, of course, what we'd like to do is to find what is the appropriate value of B null and B1. Yeah. Yeah, in terms of mathematical formulation, yeah, this is the actual regression line, and this is the estimations. Yeah, the estimations, of course, since we try to build a linear regression function, yeah, because this is linear regression, and then you try to build linear regression, then the function will also use linear function, which y yeah, is equal to specific constant plus constant of the dependent variable. Yeah. So yeah, this is an intercept. What does intercept means? Yeah, it means that if the x value is 0, equals to 0, then we have the estimated value of the independent variable. Yeah, that is the intercept. Yeah, intercept from the value of 0, and then and then the B1 is the constant. Yeah, and then the idea is to yeah, once again to find a function, yeah, a linear function with linear function. Yeah, the idea is to find what is the value of B null and B1, which will then lead us to the minimum value of prediction error. The minimum which will minimize the sum of the square difference between the actual value and the predicted value out of the regression function. Yeah, I think that's for now for the fundament, and then in the next session we will discuss how to calculate B0 and B1. Yeah, how to get the functions constant. Okay. Okay, so this is for the first session. I will continue later.